All right, so the next thing we're going to take a look at here are some of the trends, just a few of the trends that we're going to see in the periodic table. So we're going to call these periodic trends. And this is just another feature of the periodic table where we can predict the characteristic of elements just based on where they happen to be in or on the periodic table. And the first thing that we're going to take a look at here, first trend, is the trend in valence electrons. So we just had a discussion about electrons and why they are important and why the valence electrons specifically are important. And what we're going to see in terms of the valence electrons, and you can confirm this by writing out your electron arrangements, is that the number of valence electrons that an element has is simply equal to the group number, right? And remember, that's the A group number. And when we look at our periodic trends, we're going to be looking specifically at the main group or the representative elements, right? Because that's where the trends tend to hold true. So what does this trend actually says? So the number of valence electrons is simply equal to the group number. And again, these are general trends. There are always going to be exceptions. We'll talk about one exception here in a second. So if I ask you, for example, how many valence electrons does chlorine have? Okay, so the first thing we need to do, so let's see, number of valence electrons. I'm going to abbreviate valence as VAL in a chlorine atom. First thing I want to do is to find chlorine. Here it is. And then you need to remember now what group chlorine is. So we number the groups. So this is 1A, this is 2A, then 3A is this one, then 4A, 5A, 6A, 7A, and 8A. Well, we wrote out the electron arrangement for chlorine before, right? We said that chlorine was, we had to go across 2, and then we had to go across 8 more elements, and then 1, 2, 3, 4, 5, 6, 7 to get to chlorine. So the electron arrangement for chlorine was 2.8.7. Well, guess what? Chlorine is in group 7A. So the group number is actually equal to the number of valence electrons. That is the first trend you were seeing here. Valence electrons is simply equal to the group number, right? If you look at something like aluminum, okay, aluminum is in group 3. So we would assume then that aluminum is going to have 3 valence electrons. Okay, just based on that trend, and we can confirm that if you write the electron arrangement for aluminum, it would be 2.8.3. So it's got 3 valence electrons. All right, so we can quickly determine the valence electrons because that is the starting point for a lot of chemistry stuff that we're going to see in the next couple weeks. There's one important exception to this, okay, and that is helium. Okay, so helium over here, okay, it is in group 8, so we would assume that it's going to have 8 valence electrons, but it actually only has 2 because it only has 2 electrons to begin with, right? Can't have 8 because it only has 2. Compared to the other elements that are underneath it, the other noble gases, right? Those are the group 8 elements. And they all the other ones have 8 because they're in group 8. All right, so generally, it's very, very easy to determine for the representative or the main group elements how many valence electrons, right? You can go through and write out your electron arrangements if you wanted to, or you can just use the shortcut from the periodic table and equate the group number to the number of valence electrons. That's the first trend that we're going to see, the trend in valence electrons. The second trend is the trend in atomic size, which we often represent as the atomic radius. All right, so this is the size of the atom. So again, if you think about an atom as being roughly spherical in shape, the radius is going to be this distance. So obviously then the larger the radius, the larger the atom is going to be. And the trend in the periodic table for the size of the atom is a really simple trend. And again, this is for the representative elements. So groups 1, 2, and then 3 through 8. The elements increase in size as you go from right to left. And then as you go from top to bottom, the elements increase in size as well. So generally, what you're going to see is as you go from the top right to the lower left portion of the periodic table, the size of the atom increases. And we can actually put some numbers behind this. So if you have something like, let's take a look at here. So this is a chart that shows the actual sizes of the radii of the different atoms for the representative elements. So the lower left side of the table, so cesium, for instance, has an atomic radius of 265. And the units here, let's check out the units, should be picometers. Yes, so picometers compared to something like rubidium, Rb, that's right above it, has a radius of 248, so it's smaller. So generally, as you go down the group, the atom gets bigger. As you go from right to left across a period, the atom gets bigger as well. Right, so those are the two main trends that you're going to see in the periodic table: the size and then also the valence electrons. Okay, so the third and the last trend that we'll see for now is the trend in metallic character. And the trend here is actually really similar. It's actually the same trend as we saw with the atomic radius. And it goes back to when we first introduced the periodic table. We saw that generally on the left side of the table, right, we have our metals, and then on the right side, we had our non-metals. So generally, our metals are going to be found towards the left. So metallic character is going to increase in that general direction. And then also as you go down a group, the metallic character would increase as well, right? So for example, if again, you don't have to memorize any of the sizes of the elements or the atomic radii or anything like that. But if we were to say, for instance, I give you some options here. So let's say we have the following 4 elements. So consider oxygen, consider fluorine, consider sulfur, and also chlorine or Cl. And out of those 4, we're asked which is the largest atom, and then which is the least metallic. So you want to find those elements on the periodic table. So locate them, and they happen to be O, F, S, and Cl. They're right here. They form a nice little square. And that means it's going to be a little bit easier now to apply the trend to these 4 elements. So the largest atom, so atom size increases going right to left, and then also going down. So the largest one should be down and to the left. So that would be sulfur. We can predict is going to be the largest. And then that is the same trend for metallic character. So the most metallic will be to the lower left, which means the least metallic then has to be in the opposite direction, which would be the upper right side. So that would be fluorine, or F. So when you're comparing, when you have to rank the elements, find them on the periodic table and then apply the general trend in whatever characteristic or property you're looking at.